Okay, welcome back. So we'll continue where we left in the previous module. We were looking at this particular slide, and if you remember, we looked at this inventory of a light bulb at the last slide before towards the end of the last module, and then we were looking at how you can calculate. You can go from 1 unit of the material to the reference flow. We already did those calculation. So that was kind of the end of the last module. So again, just kind of quick recap. So this was the example, because I'll be continuing this example in terms of the life cycle impact, as well as we'll look at the LCI, which we started preparing it during the last module, and we'll also look at the impact statement as well as the interpretation coming out of this particular exercise. So this was the problem. We had this, we were trying to find out what is the life cycle analysis comparison between the incandescent light bulb and compact fluorescent light bulb. So these two types of, then we also had this particular table, and I told you that you should try to have this table for each and every problem you work on. This really helps. So we looked at that function for both of them is lightning. I'm going a little bit faster on that because we already covered it in the previous module. Just a recap. Primary function was the lightning, the secondary function was the heating and or creating an ambience. I told you that we will just focus on the lightning part. We will not worry too much about the heating and creating an ambience. In this particular example, we took the functional unit of 700 lumens, and the reason we took that because it gives and for 10,000 hours. Reason we did that because it gives a nice number of 10 bulbs and 1 bulbs for comparison, and 10 bulbs at 60 watt become 600 kilowatt, 600 kilowatt hours of electricity, and 1 bulb for 14 kilowatt hour of electricity. Key parameters were lifetime watt per lumen ratio. So we also looked at, this was the last slide we looked at, just we need bulb, cardboard, electricity. For the product system, the functional unit we chose this 700 lumens for 10,000 hours. As I said, you can come up with any of these numbers. It doesn't have to be 700 lumens for 10,000 hours. The reason I took that because it gives me a nice 1 and 10, 1 bulb for one category and the 10 bulb for the other categories. Then we had the reference flow. Reference flow is what is providing for 700 lumens for 10,000 hours, how much of glass, how much of cardboard, what is the electricity we need, and this is for incandescent bulb. So unit process, as the name suggests, unit process, so it will be for 1 unit. So for 1 kg of glass, these were the inputs and these are the output. We already discussed that, and we have only taken 3 parameters, but there could be a lot more there. Same thing for 1 kg of cardboard, 1 kilowatt hour of electricity. Remember, we talked about the water, like too much water is being used, and emissions in terms of carbon dioxide, particulate matter, as well as the benzene. So this is again, this is not a complete list. This is just an example list for us to work with. And for the complete list, as we do in the real exercise, you will be using database. And from the database, you can actually pull in for 1 kg of glass, what are the input required and what are the emissions coming out. So now this is for 1 kg, we need for 228 grams of glass. So we can just do the math. So per functional unit, we have calculated that for if for 1 kg we need 94 grams. So for 228 grams, we'll need 21 gram of crude oil. So similarly, you can calculate other stuff in terms of both input as well as the output. Same thing can be done for this. So this was the last slide we looked into the previous module. Now we will continue this example. So as you can see, we have lots of data just for assuming 3 parameters for input and 3 parameters for output. We are having just for this bulb, and we have only taken glass, cardboard, and the electricity. As you know, if you remember from the previous slide, no, glass was only one component. There is some aluminum here, there is some phosphorus here, there is a lot of other components which goes into making this bulb as well. So the list will be too exhaustive. So to take care of these kind of list, that's why we need the database. Database is needed, otherwise you have to we spend a lot of time on the Excel spreadsheet, and sometimes it will take forever. Say if you want to do and this is, I'm just talking about a bulb, and if you think about doing for a plant, say if you have to design, I told you that in last around 2 years back, like my research team, me and my students, we did a life cycle analysis for different waste management options for a city, for a like a group of 3 cities actually. They're called a Peel region, which is near Toronto city in Ontario, Canada. So just for the bulb, if it takes so much of effort, so think about that solid waste management system. So in terms, you will have lots and lots of Excel spread, like you will have multiple Excel spreadsheet, lots of data points within Excel, and then if you're doing a master's or PhD thesis based on that, it will take you forever to do it. So that's why databases are important. So this is our elementary flow, the input and output that you saw: iron ore, crude oil, water, wood, solar energy, land use. These are our input that is going into the system. Output coming out, carbon dioxide, sulfur oxide like SOx, particulate matter, VOCs, phosphate, nitrate, pesticides, metals, and on the both top as well as bottom, the dot dot dot, that illustrates that there is much more there. So inventory may count hundreds of different elementary flows. So it gets very hard to interpret, because if you have so much data, how to make sense of so much data? Our brain can also cannot really synthesize all this data together. So it has been said that brain can simultaneously consider only up to 9 independent parameters. So sorry, up to only 7 independent parameters. So brain cannot take more than 7 independent parameters. So if you have huge data set, it becomes difficult for us to understand and for us to comprehend. So for that matter, what we do, we neglect, as you can see towards the end of we neglect the process in the process tree which contributes to less than 0.1% of the environmental load. So if we have less than 0.1%, we don't include them. So how we'll go about it? So what we do is we do a quick LCA at the beginning, kind of gets quick and like even in the experimental lab. See, many times before you go for your big experimental design, you run a quick and dirty experiment just to see whether it's really worth going for that big, because when you design an experimental plan, it requires an effort. So you may want to do a quick and dirty, just a quick test to find out, yes, it is going to work, looks like there is a potential. So similarly here we do a quick LCA where we use several units as a black box, you can say, and then we see which is creating more impact, and then we focus on that. Anything which has an impact of less than 0.1% of the total environmental load, we can eliminate that, because again, that's a drawback of doing of an LCA exercise. But see, again, any exercise you do, there is some assumptions that you have to make. There will be some limitations. So that's so this data, where this data is coming from. So this is one example of where the data is coming from. And since as most of, if you are familiar with the environmental industry or the environmental stuff working around the world, you know that most of the new initiatives in the environmental field actually starts from the Western European countries. So this LCA is not an exception. It is also again the same way. It's as you can see, this figure shows a group of Swiss organization. So the figure here, you can see that there is a group of Swiss organization, 1, 2, 3, 4, 5, 6. Here 6 of them we have listed, and the list keeps on growing and growing. So what they have, this is a Swiss organization that joined forces to create the Ecoinvent database. So now Ecoinvent is actually kind of a company which is trying to collect data and from around the world. So they started from the Western European countries. Within the Western European countries, basically started from Switzerland, and from Switzerland, as you can, they took these 6 organizations. That's one organization here have the transport data. This has basic chemicals data. Here they have the energy supply data. This one has agricultural data, then some plastics, paperboard, basic chemicals, detergents, and metals, construction material, wood, and basic chemicals. So there are some overlaps as well. So all this data that they have. Now when we say data, what do we mean by that? So data means to make one, say for example, making 1 liter of petrol, or 1 kg of steel, or 1 ton of steel, or any unit you can think of, sorry, any product or material you can think of, a unit of that. So to make 1 unit of that particular, say 1 kg, 1 kilowatt hour of electricity, or 1 gigawatt hour of electricity using coal based thermal power plant, or using gas like a liquid natural gas, or using for example hydroelectric power, or nuclear power, or geothermal, whatever, solar power. So for all these different energy sources to produce one unit of that energy, what are the different inputs that is needed in the system? So if you think about the solar panel, for example, solar panel, it's a solar panel, it's a physical thing. So it is the certain material, whatever we make, we need material to make them. So it does uses some material. And so what are those material? So to produce 1 kilowatt hour of electricity or 1 gigawatt hour of electricity using, say, solar panels, how much material will be needed? What are those materials? What are the basic kind of chemical composition of all those materials? And whether those materials are mined, or what is the source of those materials? What is the environmental footprint associated with getting those materials to make the solar panel? What are the waste coming out during the making of the solar panel? When the solar panel is used, does it require any of the maintenance? What kind of maintenance it requires? What kind of service it requires? And then also when it's disposed, what happens to that material? So all these things together, so that will be your say for 1 kilowatt hour, 1 kilowatt of electricity from solar panel, we can calculate what are the different inputs and what are the different outputs. So for these kind of data, for this particular central database, this we have here in which is developed now, it is called Ecoinvent. Ecoinvent has been developed taking into consideration the data that came from these 6 organizations at first, and then the Ecoinvent, it's a company, as I said earlier, it is trying to develop its own database. So as I said, as I told you in your previous module, that right now we are working with Ecoinvent. When I say we, like myself and my students, we are working on a project with Ecoinvent to develop data in India. So there are a lot of other areas where they are working on. This present project of Ecoinvent that we are associated with is focused on textile. So it's a textile industry. How to collect the data in the textile industry in terms of its what are the chemical release from there, what are the different chemicals they use, how much energy is required, how much water is required. So we are collecting all those informations from a textile industry in southern India. So that's and then there is a standard format in which it needs to be put together. So it would be better to do. So and then if you think about why we need all this data. Again, what is this LCA exercise? LCA exercise is basically you are doing a data compilation for all the input parameters, all the output parameters. Now, why we do data compilation? Because we are interested in to find out what are the environmental impacts associated with any of these processes or product. So that's the goal of doing this life cycle analysis. So the central database came initially from these 6 sources. Now Ecoinvent is trying to collect more data from different sources. So Ecoinvent is one example. There are other examples out there as well. There is I have a list of some of those towards the end of the presentation, where towards the end of the video probably you will see the different organizations which have the data, and some of these are free data. Free data means like you and me are already paying through the taxpayers' money, or whoever is paying taxes, and some of these are paid, like for Ecoinvent now is a paid service. So you have to get the paid service. For non-OECD countries, of which India is a non-OECD country, you can get access to Ecoinvent free of cost for educational purposes only. So for teaching and for student projects which is not funded through any other organization, we can use Ecoinvent database. So that is available. You can go to Ecoinvent website and try to download that, but if you don't, you can send me an email and I can always help you to pinpoint in the right direction. But it's not that you go to Ecoinvent web page and try to buy this product. There it will say for the non-OECD countries, including India, we can get access to this database without any charge. But that's only for educational purposes, not for consulting, not for industry, only for educational purposes. So we had this elementary flow, this input and output, what is going into the system, what is coming out of. So from this input and output, now we looked what we have done so far, we looked at the life cycle inventory part. We looked at the inventory part. Now we'll look at the impact part. So what is the, in terms of the impact? So these are the input and output. This is our LCI. This input and output that we have quantified, that's the LCI, life cycle inventory. This is what we call as life cycle inventory, and we have done it for elementary flows. So we looked at our unit flow from the database or from and then we calculated for our whatever we need for our particular example. Here we were looking at the bulb. So ultimately we are interested in the environmental impact. So what kind of impact we are interested in? So there are different impact categories out there. So as you can see over the list over here, global warming. Global warming is it's a term used for climate change as well. So it's a climate change is a more general word, and global warming is the word which is being used earlier. Nowadays, we mostly call it say climate change, because global warming gets a wrong impression. Global warming seems to say that everything is getting heated up, but that's not the case. The case is climate change. When they say, even when they say global warming, they're saying that the temperature at the cooler places, things are maybe becoming cooler. At the hotter places, things may become hotter. Or also we are seeing a shift in the pattern. Places where it doesn't used to rain, it rains a lot. The places where it used to rain quite a bit, it's not raining. So that's all kind of comes under this climate change. Then that's one category, one important category. Then we have ozone layer depletion because of release of these greenhouse gases. We have this ozone layer. Why the ozone layer is important? Because the ozone layer helps us from getting exposed to the radiative rays, which if you like ultraviolet rays, which can have a negative impact on our body. So we are getting a so ozone layer is like acts as a protection layer. So change in land use because of impact, there could be a change in land use. Natural resource depletion, natural resources going down, so that's another issue. Acidification, especially if it's SOx, NOx, you see here SO2, NO3. So SOx and NOx, so that's the acid rain. Carbon dioxide also lead to reduction in your in the pH. So acidification is a problem. What is the problem with acidification? Because acidification will lead to, say, you must have heard about, you may have heard about acid mine drainage. So acidification leads to what happens in the lower acidification means lower pH. Lower pH means metal comes into solution. Many of these contaminants which remains in a precipitate form, once the pH goes down, it tends to come in solution. So what does that mean? When it means in solution, means if it's a after acidification, if there is a rainfall and our contaminated soil, sediment, whatever, it's a contaminated soil, for example, many times we hear in that mine area as well. So in those where we have this acidification happening, our metals will get dissolved, and next time when it rains, the metal will get into this rainwater and can potentially go to the surface water. So that's the problem with acidification. Then eutrophication. If you are an environmental, if you have taken any course in environmental science or engineering, you probably must know eutrophication. Eutrophication is when you have the nitrate and phosphate getting into a surface water where you have a algal bloom. Everything looks very green, but what happens is it kind of covers a layer on top. It doesn't let oxygen go into the deep water, and the species in deep water suffers for that. So and it also, so that's the problem with the eutrophication. Now the photochemical ozone generation, that's another one from the photochemical ozone generation, human toxicity, ecotoxicity. So all that, there are different impact categories. Again, these are some of the impact categories. These may not be the complete exhaustive list. You may have to look at the complete exhaustive list, and for depending on where you are, some of these impact categories may be of much more importance to you than the other. So you need to be careful with that as well, like which impact category is more important for depending on where you are. So from there we come up with a single score, as you can see over here. So we come up with this impact categories, so that's your life cycle impact assessment, and then we come to the single score. Now why single score? Again, as I've been telling you earlier as well, you should always be worried about, you should always be asking question, okay, why we are doing this. So why single score? Single score because to help a common person understand the impact from any product or process. Say if you talk about all these different impact categories, global warming, ozone layer, land use, natural resources, and they may sound very technical, but it's very difficult to quantify, very difficult to actually educate the common people with all these technical jargons associated with that, like eutrophication or photochemical ozone. So people who are not familiar with this, they get so much afraid of these, or they just don't want to even learn about all that. To make things simpler, like we do for say for example Bombay Stock Exchange or National Stock Exchange, or for that matter New York Stock Exchange, any stock exchange, they have a number, they have a single score, and that single score tells you that whether the market is going up or market is going down. That's your Sensex, isn't it? We call it Sensex index. Sensex, maybe usually it is a combination of 100 companies, and out of those 100 companies, some may have done well on that day, some may have done bad, but based on if the majority have done well, and then things have looks up, so then you see a increase in the BSE Sensex. If the majority has done poorly, you see a decrease in the BSE Sensex. So similarly over here, if you see a higher score than a bench score, that means things are better in terms of the environmental impact. But if you look at a lower score than the bench score, that means things are actually not that good from the environmental standpoint. So that's the reason to have a single score, so that you can convey this to say politicians, policy makers, or bureaucrats who may not have that much of a technical background. To explain them all, you need something like a single score to compare different products, different processes. So that's the reason we do the single score, and not only in this particular life cycle analysis thing. This is also done for the water. You hear about water quality index, you hear about air quality index. So this water quality index, air quality index, all those index are again based on single score to help the layman understand the numbers, in a simple way, the impact coming from a certain scenario. So there are different approaches of going for the impact categories. So you have your elementary flow, which was your elementary flow, this input and output system. Then we have these impact categories. Here, if you can see, we have more lists than what we had here. So we have added some more list over here: human toxicity, respiratory effect, ionization, radiation, photochemical, aquatic ecotoxicity, terrestrial eco. So there is a lot more things have been added to over here. And from these impact categories, we go to what is known as the damage categories. Now, what is damage categories is essentially you go in terms of what kind of damage we are going to see, whether it's an impact on human health, whether it is impact on ecosystem quality, whether it is an impact on climate change, or whether it's a resources. And for that, some of these impact here from the impact categories, it doesn't mean that one will only go to one of these damage categories. They may have a multiple relationship as well, and in that case again we have to kind of do a weighted average in terms of we have to divide in terms of allocate this percent to this category, this percent to that category. So there are different impact categories, and from the impact categories we have the damage categories. So these are the major damage categories. We kind of talk about human health, ecosystem quality, climate change, and resources. And this is an approach which is called Impact 2002 plus, because that's this Joliet et al. In 2003, she came up with this this particular approach. So this was this is one approach. This is again this is a popular approach. Now there is another one, Recipe 2009, which is another approach used for going for impact category to the damage category. But again, these are all different approaches. You can use the approach which you feel more comfortable with, but you need to justify why you are using that particular approach. So that's in terms of the different approaches. So again, we had this LCA result. So that's one inventory result. That's the inventory result. Then you go to the midpoint. Midpoint is where you look at this impact: radiation, smoke, carcinogen, climate, ozone layer, acidification. So these are all the impacts that you look at in terms of the midpoint. And then you look at an endpoint in terms of endpoint impact: respiratory disease, seawater level, cancer, dying forest, extinction of a species, and reduced resource base. So these are all the endpoints category out there. So you go from LCA result to midpoint to endpoint, and there are for midpoint to endpoint, when you go in terms of their impact, you need one of these methodology, either Recipe 2009 or Impact 2002 plus. So those are some of the methodology that you can use. So this is how in terms of impact assessment works. LCA results, it characterizes or produce a number of category indicators, and according to ISO, one must document the relevance of each indicator by describing the link to the endpoint. Endpoints can be selected by the practitioner, as well as the reason for including or excluding endpoints are clearly documented. So it's basically, so you go from this LCA result that you get from, remember we talked about that long table, input and output of all the different unit processes. Then you go to this midpoint, and from midpoint you go to the endpoint. And from this endpoint, you do some weighting. Weighting again depends on what is the goal, what is the goal of this study, what you want to achieve, what is your focus. So a schematic overview of the methodology. So you have its environmental models for each impact are extended up to endpoint. So we look at the up to the endpoint level as the impact category, human health, ecosystem, or resource base, and so some impact category may relate to the same endpoint. There could be kind of a cross as well. So there could be some of these also relate to ecosystem, and some of these also relates to human health. But we need to look at that like in terms of overall, like what are the different impacts that's coming out here. So once you have this, you can do some weighting, and then you try to come up with interpretation in terms of which one is more important and how to go about that. So what in terms of the implementation plan of LCA, first of all, goal is why use LCA. You need to find out what is the use of LCA, what is which application, who are the results reported, as to who will be the person, who is the audience, who will do it. Then you interface with your organization, you try to talk with the organization people, you come up with your eco design, you come up with strategy development, product declaration, benchmarking process, life cycle costing. Then keeping these things in mind, you approach your LCA experts either within the company or outside the company. Then you get the LCA exercise done, you take it to the environmental management system specialist, so, and then also product manager, designers, who will all be working on certain projects as well. So keeping all these like the endpoint coming out, you can communicate with all these different stakeholders and to have a better design for that. So let's kind of stop over here for this particular module. So what we did in terms of this module, I kind of gave you a overview of how we go from lifecycle inventory to impact and to interpretation. So that's what we have been looking at. And then again, it's very important. So if you have any questions, feel free to like send us on our like the post, the discussion board, and we will be happy to answer those questions as well. And don't forget to tape your weekly quiz. So weekly quizzes are designed so that it helps you to like learn better. So with that, let's close this particular video, and then we'll get back again on the we'll continue with this exercise in the next module as well. Thank you.